From Trimble Construction, you're listening to the Connected Construction Show, where we connect you to the contractors, owners, designers, engineers, and construction professionals who are finding better ways to work. And now, here's your host, Matt Sprague.
Hello, everybody, and welcome back to the Connected Construction Show. As always, I am your host, Matt Sprague. We are still here at Dimensions 2022, Las Vegas, Nevada, at the, where are we? We're at the Venetian Resort and Casino. Super excited to be here and super excited to have my guests, Fredrik and Kevin. Thanks, you guys, so much for joining the show.
Thanks for having us.
Thank you. So, tell the audience a little bit about yourselves. I won't do the injustice of trying to introduce you. You guys will do it better than me. Tell us who you are, who you work for, what your title is, but more importantly, how you get to be where you are today. What's been your path through the industry? So, who wants to go first?
Sure. I'll go first. My name is Kevin Andrews. I'm the Strategic Marketing Manager for Trimble Autonomy, which means my current role is helping a bunch of different groups within Trimble organize their long-term plans around autonomous technologies and product development. My background is in navigation engineering. I have an engineering degree from the University of Calgary. I got on the autonomy path, I think, in around 2004 when we sponsored the DARPA Grand Challenge, which was one of the first attempts to really build an autonomous car. They had to go like 100 miles through the desert, and nobody really knew if they could even do it. So we got to work with groups like Carnegie Mellon and Stanford University, some of the biggest nerds in the world, to try and just prove that this could be done. And it was a lot of fun to be a part of those teams, and obviously the technology worked eventually. I think about the third try, they finally got it working, and yeah, we just kept it going. We got into industry, we got into farming and ag and all kinds of different stuff, and here we are, just keeping it going. Yeah,
the applications are endless, and that's what we're going to talk about today.
Definitely.
It's a lot about autonomy. But Fredrik.
Yes, Fredrik Åkesson, Swedish national, born and raised in Karlskrona with the Dynapac factories. I've had about 25 years with Dynapac now, working in product management, application support, supporting our end users, sales team, with training, how to use the equipment in the most efficient way, select equipment, where to use it, and trying to be as efficient as possible. And we had, I think, 5.5-6 years back, partnered up with Trimble on the autonomy side. So I have been in my role as portfolio manager back then, connecting point. Now on the application side, I'm even more deeply involved in the project, supporting Trimble and the development on how to use the autonomy for soil compaction, which is our first go where Dynapac is involved. So it's an interesting journey. Awesome. But it's only just started, I would say, from our side.
Yeah.
Whereas autonomy has a much longer history in other industries, but for us, it's fresh. It's nice.
That's awesome. And I think a little bit later in this episode, I want to dive into a little bit more in terms of what you guys are working on together when it comes to autonomy. But I want to lift it a little bit higher. I always like to kind of utilize myself as the potential idiot here that doesn't understand everything. So from a pretty high level, let's talk about autonomy in construction. So the first thing, obviously, I think of is autonomous road vehicles. And that's probably what the majority of the public will think of. But there are uses of autonomy in different industries, but more specifically in construction. So what is that? What problems are being solved?
You're right. That definitely passenger vehicles are the first thing most people think of. There's like robo-taxis that are out on the road now. Like apparently Lyft and Motional have a robo-taxi operating in Vegas. It's been my goal to get on one. I think I'm preparing myself for disappointment. It only operates, I think, in certain times. But yeah, talk about the problems that we've been trying to solve. Trimble has been in autonomy in the way we define it since like the late 90s when we started building these great control systems. And we define that as autonomy because anything that sort of goes through the sense, think, act cycle is what we call autonomy. So if it senses the world around it, thinks and tries to make a decision about what to do about it, and then acts in some way, then we kind of define that as autonomy. So even like a visual indicator for the operator to say, your blade's got to go up or down or left or right or something like that. That still kind of counts. It's at the very low level of autonomy.
It's an autonomous decision.
It is, yeah. It is. We call that partial autonomy. There are a couple of other different things. There's lots and lots of opportunities in just about every industry to bring a little bit more intelligence in, bring some sensors in, bring some thought into it, and start solving real problems.
Yeah, no, I agree. That's the very point. To find the problem and then to find the solution for it. We've been with Dynapac the past 30 years or so, looking at various ways to help the operators do a better job. You have, since the mid-90s somewhere, recording, measuring the stiffness of the ground, giving that feedback to the operator to make decisions. So there is sort of a guidance system there. Next step was to add GPS receivers, which it was sort of mid-2004, 2005, enhancing it a little bit further so you can see your pass count map, you bring it forward one step. And then now with this information, we'll be able to eventually take the operator out of the equation, so to speak. And there are some benefits with that. There are some setbacks as well, maybe initially, but like we're doing today, we instruct the operator to run a certain number of passes. Let's say you should do 6 passes to cover an area. That's a good start, because somewhere in a test track we determined 6 passes is the target. That will get us to the level of quality that we need. So we instruct the operator to do that. Does that mean that 6 passes will be made? Maybe on a good day, on a good operator, we get that kind of result with various overlaps and various efficiency issues. If we have a machine that we instruct to do the same thing, we can control that much more in detail. We get the right number of passes. We can minimize the overlaps. We can improve the efficiency and have a greater transparency as well. We know exactly what's happening. When we get to that point, then the benefits, I think, will become obvious. When you compare, when you see the outcome, and when those benefits exceed the initial input, because with any investment, you have an investment first and then it starts to pay off. It will be the same with this. It's a learning curve for us, for the end users, and for everybody involved in this. And I think it has a brilliant future. More for some projects than for others. But obviously, that is the thing. We need to figure out, together with you guys, together with the customers, where are we going? Who's sort of leading this? What are the initial projects we want to go to, and how do we address that? And then it will be, I think, a pull from the market when you start seeing the benefits.
So it's, I think it was Rob Painter, the Trimble CEO, in the keynote yesterday. I listened to a lot of different sessions, but he was talking about the effect of sustainability. I think he brought up a compaction example. But now it's what I'm also hearing is that, and he didn't, I don't think it was specifically around autonomy, but it was around, measurement and bringing a feedback loop in to say 6 passes should do it. But if all of a sudden 4 hits the compaction that you need, then it would stop. So is there is the future, or is it current, that we're marrying autonomy with sensors and actual measurement to try to create greater efficiency? I just come up with $1 billion idea.
No, you're right. It's really what Fredrik mentioned overlap, and that's really one of the biggest ways that autonomy can make savings. If we apply this in ag, we apply it in construction. As you're trying to cover an area with a machine, and you've got maybe you have to do like 5 rows, but a human operator is going to tend to put in more overlap because they don't want to make any misses. Misses, you got to go back and do it again. Yeah. So we talk about overlap in terms of percentage, and I think you got a number today of like 40%. Yeah. So 40% of this lap is going to get covered again as he comes back in the other direction. Well, that's 40% waste. Like, you don't want to do that twice. So if you can really precisely get those edges right up against each other, then that's where the savings come. We see it a lot in ag as well. Like, we do a lot of precision farming has been a big thing for Trimble, and it's the exact same concept. You can keep on the straight and narrow path, and then cut right against it on the way back. Then you can see some real savings. And I think those are the numbers that Rob was quoting. Was that kind of fuel savings? Yeah, the fuel savings. Very, very direct saving when you look at the overlaps. I mean, when we calculate on a machine recommendation, machine capacity,
we're at about 10% overlap between parallel passes, whereas in reality, I was just visiting a session on where they made a study on that, and reality was between 45 and 55%. So already there is a huge savings potential with just the horizontal steering that we have today. Now the next step, as you mentioned, when you start to add sensors to the system, which is definitely in my vision where to take this, because like you're saying, 6 passes, that's the instructions today, for lack of a better understanding, because we're working with materials that are extremely inhomogeneous. And just as you said, 6 passes is not the universal solution. It's the best thing we can do today. But maybe it should be 3 passes here on low amplitude and 2 passes on high amplitude over there.
Yeah.
And then another few perhaps to cover it off. And when the machine has the sensors and the algorithms to decide on that, then we get to the next, or maybe the level after that. And then the efficiency gains will be even higher. And of course, making every pass count. I think that's a goal that is in the US for the asphalt works. But it's just as important for the soil works. And running with diesel, yes, there is cost saving if we reduce the number of passes. If we go to alternative fuels, you might have to optimize in order to get the working hours out of the machine. The waste becomes so much more expensive that you really have to optimize to get it running. And those tools, these kind of tools will take us there eventually.
So is it also a schedule impact in terms of, if I'm not an expert in compaction, but if the compaction project is going to take 20 hours to complete, you're able to, obviously, there's no operator that needs a break. It can continue to roll. It can go throughout the evening and be done in the morning.
Yeah, there's a couple of different ways where you get that kind of savings. One is if you know you're going to be able to precisely execute your plan, then you can budget for it more precisely. You don't have to put as much waste in your estimates.
Yep.
Right? Because if you know, okay, it's going to take us 10 hours, but it's a human operator, so plus or minus 2. Well, I got to account for that. But if it's going to be a machine, it's going to be 10 hours plus or minus 10 minutes. Then you can really get your budgeting down, and you can do that sort of thing really well as well. But the other interesting anecdote I heard somewhere along the path was just not using the machine when you don't need it. So a human operator, if they're done, but they still got like another 20 minutes in their day, they'll just keep going because they don't want to seem idle. So they're burning gas and they're compacting areas that don't need to be compacted just to look busy.
Yeah. If you
can turn the machine off when you're not using it, there's a huge amount of savings there, which is kind of a crazy idea, but it's very real.
Yeah.
It has a quality impact as well, because if you're over-compacting with too many passes, you risk breaking down the material, and then you lose the properties that you're actually looking for. So it has multiple levels of impact, actually. So it will be quite interesting to follow, see what we end up.
Yeah. So Fredrik, talk to us about Dynapac. So we know Trimble well.
Yeah.
If not, I've got a problem. But tell us a little bit more about Dynapac.
I'd be happy to. We are machine manufacturer, Swedish origin. Started in 1934 when 3 gentlemen bought a French patent on concrete vibrators. So vibratory compaction was the start of the company. It then evolved over the years to vibratory soil compactors, vibratory double drums. A lot of this development was driven by a real legend, I would say, in the compaction industry, Dr. Lars Hoskdal, who was research director of Dynapac for a number of years and really strongly, I would say, informing, training, and really driving the development of vibratory compaction. Dynapac today is French-owned. We're since 2017 owned by a French family company, the Faya Group. We are active in, we have manufacturing in Sweden, which is my base. We have manufacturing in Germany for asphalt pavers, Brazil for rollers, mainly for South America. We find the factories in India, in Pune, and in Tianjin in China. So from being a small factory in a basement in Stockholm, it's now a really truly global company, not to the size of Trimble, but catering to the niche market that Dynapac has with rollers, single drum for soil compaction, double drum for asphalt compaction, and the pavers for paving asphalt, of course.
Awesome. So now, the relationship with Trimble, like where did this start? Where is it now?
Well, I think it started. I wasn't directly involved, but it started a number of years ago when the Trimble's research group into autonomy was really looking for partners. We need people with the real world problems to solve. We need people with machines. We need OEM partners because you can't really go to a strange OEM and try and do the system integration because they might not want you there and they may not want to share the protocols and stuff. So Trimble's always looking for a good OEM partner that's willing to try new things and get out there and experiment and sort of help us work through some of the bugs. So I think that's where Dynapac came in.
As I understand it was a discussion between a representative of ours and a representative of yours, and they figured out why don't we give it a shot and see what happens. We'll form a loosely moderated partnership and see where it takes us, basically, which is taken us quite far.
Yeah.
In what are we, 3-4 years into it?
Yeah.
Something like that. Moving on.
So you mentioned that it's technology between the two companies is in the test phase. So like, is it just as simple as it's autonomy on compaction machines, or is it what exactly are we trying to solve?
Well, we do have finished products that are out there first. So like a lot of Trimble's construction applications, the speed control and steering control systems that we've put out on a number of different things are also been applied to the Dynapac compactor. There was a release this year around steering control. So the operator is still in the vehicle, but it's steering itself and executing its plans. It's using our new sort of path planning technology, which is modeling how vehicles turn really accurately and planning that mission of minimized overlap and minimized amount of time. So those products are released into the market today. But the idea of the driverless compactor is still sort of in the not science fiction phase. It's out at the off-road. So if you want to go see it, go see it. But it's we're looking to build up some more experience, I think, before it's ready for prime time.
Yeah. Do you think there's people need to be ready for it? Like, will people be freaked out by it? Like, wait a minute, that thing's running on its own. Like, are you experiencing that type of impression?
Not so much, and a big part of that comes from we're starting to see it in our everyday with things like cars. So we're like get a robotic vacuum cleaner, right? I mean, these aren't crazy concepts anymore. Is much more controlled. Exactly. Yeah. So safety is obviously a huge impact, and that's something that Trimble has to think about when we're designing these products. Not just can we make the machine safe so that it doesn't do anything dangerous, but also in product design we have to make sure that as we're designing it so that it fails safe. If a sensor breaks, if we understand how sensors can break or fail, and we've got to make sure that we have designed it so that in those instances the system shuts itself down, behaves in a safe manner, or adapts accordingly. And we're doing that because we know that probably regulation is coming to say that product design must meet certain standards around safety, and we need to be ready for that.
That's awesome.
In my experience, or the latest discussions we've had, it's rather there is a pull from certain contractors, the early adopters, saying, we want this yesterday, but if we can have it tomorrow, we'll be almost happy, but when can we get it? I mean, there is an actual pull, not from everybody, but from the more progressive ones.
The early adopters.
Who are suffering today also from the difficulties of finding laborers for this. They have the engineers, and maybe they can raise the bar saying, hey, if you want to do this with Compaction, you don't have to sit at the machine. You can do programming, you can sit at your computer. And then all of a sudden, hey, this is also what I do in my free time. And I can get paid doing it. Oh, perfect.
Yeah.
I'll go there any day.
Yeah, the labor shortage is definitely something. I heard something yesterday, and I can't remember what state Department of Transportation here in the U.S. was talking about it, but they had like 1,300 construction inspectors, and the average age is 60.
Yeah, that's good.
So, like, Event Horizon.
Yep. We've certainly seen in the last few years that people that were reaching retire age or thinking about retiring, COVID kind of made the decision for them in a lot of cases, and they thought, okay, this is a good year to get out. So we are seeing that big baby boomer generation finally go into retirement, and the number of people that are coming up just the demand is growing. We always need more stuff. We always need more things constructed. We need more food. We need all kinds of stuff. But the people that are coming up, it's not as big a generation, so they have to do more with less.
Yeah.
And they're going to need technology. And the good news is they love technology. I mean, the generations that are coming up are so familiar with this technology that they trust it. They trust it more than we do, I think, in a lot of ways. Maybe more than they should sometimes.
Well, awesome. So here's the last question that I promised. So everybody that's watching or listening, I'm going to be fair to them in that I only asked them this question right before we started recording. But what is your motto, or what is a motto that you've heard that you find interesting as a means to live by?
Sure, I would say, very particular to this autonomy journey that we're on, the future is hard, don't go it alone. We need partners. We need partners, OEM partners like Dynapac. We have research partners, supply partners, technology development partners. Trimble Venture is out there investing in new partners that may come along in the future.
Yeah.
So I think that's a big thing. It's building up that ecosystem.
I like that. Fredrik?
I was
on the spot.
Struggling a bit with this one, but I came up with what I think is my motto more personally, and that is work to live rather than live to work. Stay balanced. Make sure you get to do the things you want to do. And I've been fortunate enough. I've been traveling pretty much all corners of the world, 25 years with Dynapac. Extremely stimulating. The good thing is, Karlskrona, where the factory is, it's like a 70,000 people town. So when you get back there, you can relax a little bit. Vegas, to me, is not very relaxing, but when you get the balance between that, you get to experience the world.
Yeah.
Come back to a small town and have that as your base. That's a perfect way for me to balance my work life and personal life.
Yeah, no, I love it. It's the love what you do when you don't work a day in your life.
Yeah, exactly. Yeah.
Absolutely. And with Vegas, I mean, the one exception here is this booth. It shuts the rest of the city out. So it's very nice. Yeah. Well, guys, thank you so much for joining me. I really enjoyed this conversation.
Thanks for having us.
Exploring autonomy.
Thanks for the opportunity.
Yeah.
It's been great.
So, and everybody out there listening, watching, thank you very much. And until next time, stay connected.
Thank you for joining us for this episode of the Connected Construction Show. For more information, visit us at connectedconstructionshow.com.